Everyone, good morning. Dear authors and invited guests, welcome to the technical session 4C. Myself Siddhi Audi, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastics LLP, it is my great pleasure to welcome you all to the 10th International Conference on Information and Communication Technology Competitive Strategies ITCS 2025. The 10th edition of the conference is being held in a hybrid mode. The physical event was held yesterday in Jaipur, and the virtual event is being held via Zoom meeting today and tomorrow, that is 16th and 17th December. I hope you all will enjoy this knowledgeable and interactive session throughout the day. In this session, we will be having total 10 presentations, and each presenter will be given a time span of 10 minutes for their presentation, and 2 minutes will be for question and answers. On every ninth minute, I will be raising a gentle reminder. So, this is a kind request to all the participants that you all stay connected with us till the closing remarks. If you have any query or face any issue, you can write it to me in the chat box. Now, just before we start the session, I would like to introduce you all to today's session chair. Dr. Chaya Jadhav. Welcome, ma'am. Dr. Chaya is an professor at Dr. D.Y. Patil Institute of Technology, Pune, India, having total teaching experience of 26 years. She has more than 25 research papers published in international journal and conference. She has 4 copyrights and 3 patents. She is working as a subject chairman at SPPU Pune and also a PhD guide at Pune University. Welcome, ma'am. Thank you for chairing today's session.
Thank you. Am I audible?
Yes, ma'am, you are audible.
Yes. You can start
Okay,
the session.
let's proceed further. So the very first
Yes.
participant is Piyush Mohanty from Siksha Anusandhan deemed university. Sir, I request you to please start with your presentation if you have joined the meeting. And the paper title he's presenting is A Neuroinformatics Methodology to Enhance Early Detection of Alzheimer Disease. Now I'll stop sharing my screen and you can start with your presentation.
Thank you, Siddhi, for your introduction. So I'll be presenting my script. So is my screen visible?
Yes.
Yes, sir.
Okay. So, good morning, respected Dr. Chaya Jadhav ma'am, and everyone present in the virtual meet room. I am Piyush Mahanti, and I'm presenting our project titled Neuroinformatics Approach for Early Detection of Alzheimer's Disease. Our team members are Supava Devi, Sagarika Patnaik, and Mitali Madhusutta Nayak. In this project, we use advanced AI and deep learning models, mainly CNN and SVM, to detect Alzheimer's disease from MRI images using neuroinformatics techniques. Now let's move on to the presentation outline. Here is the presentation outline of our presentation. So let's begin with the introduction. Alzheimer's disease is a serious neurological disorder affecting elderly people, causing memory loss, cognitive decline, and behavioral changes. Detecting Alzheimer's early is extremely challenging because symptoms appear slowly. Therefore, our objective was to analyze MRI data and design an AI model that can detect early stages accurately before severe brain disorientation begins. Now let's move on to the motivation. Our motivation was to build an early stage Alzheimer's prediction model using advanced AI techniques. Early detection helps patients recover timely treatment, preventing rapid disease progression. We also want to spread awareness about how early screening can change patients' outcome and improve quality of life. Now let's see the uniqueness of our work. What makes our project unique is that using of both CNN and SVM model, enabling us to compare which algorithm performs better. Our approach offers a clearer understanding of Alzheimer's progression by analyzing MRI-based structural brain changes. Unlike previous models, our approach is more accurate and use stronger classification techniques. Now let's see the literature survey. We reviewed multiple research papers focusing on neuroimaging, transfer learning, and classification models. Most studies highlight the challenges of handling MRI data due to high dimensionality and noise. Additionally, many researchers emphasize the need for multimodal imaging and efficient deep learning techniques for better diagnostics. Now let's see the problem identification. We identify four main problems, which are clustering techniques fail with MRI data due to high complexity. Then, achieving high accuracy is challenging because MRI images contain noise and artifacts. Then, MRI datasets are large and require heavy computation. Then lastly, traditional methods lack robustness in identifying brain patterns. Therefore, classification-based supervised models like CNN and SVM are more suitable. So this is the schematic layout of our methodology. The pipeline starts from raw image data that are processed for consistency, where edges are detected and segmented to extract the brain areas. Hand-designed geometric features are for SVM classification purposes, while processed patches of images are given to the CNN for learning hierarchical features. Lastly, CNN and SVM predictions are combined to generate final decision result for Alzheimer's. It identifies small changes in the brain, like shrinkage and reduced activity, which are early signs of Alzheimer's disease. So these are the tools we used to develop our project with Python as our primary programming language, then Jupyter Notebook for the development of our interfaces, NumPy for numerical operations, Pickle for saving our models. Then TensorFlow was used to build the CNN model, and scikit-learn was used for SVM classifications. Now let's see the system specifications. This table shows the hardware and software configurations used in our project, ensuring environments support deep learning computations. So we use the Alzheimer's MRI dataset from Kaggle, consisting of 5,500 images under four categories, which are mild demented, very mild demented, non-demented, and moderate demented. These images were pre-processed and used to train the models. Now let's see some of the examples. These are the sample MRI images from each category, which are very mild demented, non-demented, mild demented, and moderate demented. They help the model learn the difference in brain patterns. So here we performed edge detection using OpenCV's Canny algorithm. So what this code does is that converts the MRI image to grayscale, then applies Gaussian blur to remove noise, then detects edge using canny, and finally displaces the edge-enhanced brain image. So why edge detection is needed? Because it highlights boundaries of important brain structures such as hypothalamus and ventricles, the region usually impacted in Alzheimer's disease. So this code performs image segmentation, which separates the brain region from background using thresholding. So what this code does is that converts MRI image to grayscale, then applies Otsu threshold to segment bright and dark areas and help isolate areas where Alzheimer's cause structural changes. So segmentation improves feature extraction for both CNN and SB model. Now let's see the CNN architecture. This shows the architecture of our CNN model. The input layer takes resized MRI image of 128 cross 128. 2-con-2D layer extracts facial features. Max pooling layer reduces dimensionality. Flatten layer converts feature maps into a single vector. And finally, dense layers classify the image into one of the four Alzheimer's stages. Now let's see the accuracy. The CNN model achieved an accuracy of 90%, which shows it is effective in detecting the Alzheimer's disease, but still struggles with the noise and brain pattern differences. Now let's see the SVM model. SVM is a powerful classifier suitable for smaller datasets and high dimensional features. We use feature extraction for segmented images and fed them directly to our SVM model. So the SVM model achieved a 97% of accuracy, outperforming CNN. This indicates that SVM handles the dataset better due to simpler feature patterns and clearer boundaries. So now let's see the comparison of the accuracy. The first graph shows the comparison between precision, recall,
Hello.
and F1 score.
Sir, sorry for the interruption, but we are
Yeah.
past the presentation time. Could you please get to the conclusion?
Okay, sure. So to conclude, our project successfully identified Alzheimer's pattern using MRI images. We compared CNN and SVM model and found that SVM gives the highest accuracy of 97%. Our project also provides a foundation for real-time automated Alzheimer's screening too. In the future, we aim to expand the dataset for more robustness, include multimodal imaging like PET and MRI scan, optimize algorithm for real-time prediction, collaborate with healthcare institutes, and validate with clinical trials. This will help build a reliable clinical diagnostic tool for Alzheimer's disease. And these are the references we used for our research work. So this is the end of our presentation. So thank you for your patient hearing. Thank you.
Piyush, am I
Ye-
audible?
Yes, ma'am, you're audible.
Your topic is good. Just one question. Do you have any doctor as a consultant for or support for your project? So means how you are validating your results
No, ma'am, we don't
because
have any consult.
related to the health issue. So what
Yeah.
results you are getting? Have you approved from the doctor side or like that?
No, ma'am, we didn't approve or we didn't take any consent from the doctor. We
Mm-hmm.
visualized pure AI model where the prediction is done based on the dataset we have provided. So this is the limitation where we faced, where in the future we will be collaborating with the health institute and validating their clinical trials.
Validated, na? What results you are getting, it should be uh, validate. Na? Basically, again, it is related to the health. So what results you are getting, it should be approved from the doctor, and you can say that
Yeah.
your algorithms results are good and it can be used for that.
Okay. Sure,
Okay,
ma'am.
so in future you can have a tie-up with any one of the hospital or the concerned doctors.
Yeah. Yeah. Sure, ma'am.
Good
Yeah.
presentation.
Thank you, ma'am.
Thank you, sir,
So
for
I'm
your
stop.
presentation.
Yeah. Thank you.
So the next presenter is Tejamaya from Chaitanya Bharati Institute of Technology, and the paper title is A Student-Centric Event Recommendation System Based on Graph Neural Networks and Contrastive Learning. Sir, please start with your presentation.
Yeah, thank you. Thank you. So good morning to everyone. Good morning, ma'am.
Good morning.
So I am Tejo Maya. So I would be presenting my presentation. One second. Yeah. So the title of my research is a student-centric event recommendation system based on neural networks and constitutive learning. These are my co-authors, Dr. Sheena Mohammed, ma'am, Akil Kumar Jashwant, and me. So the overview. So the college event ecosystems are dynamic, short-lived, and pre-driven. So basically, it goes on like it's very short and has a cold start. The proposed system, a student-centric event recommendation framework model on CSCL GNN model, where joint user learning from user event interaction graphs and user to user social event graphs. So I would be next showing slide. So existing systems which are using collaborative filtering and content-based filtering models, and other models are like content-aware recommendation models. The main limitations of the models are they suffer basically on the cold start problem, where cold start problem is like we don't have a new where there is a new user which doesn't have a historic pre-history of his interaction, so the model would be difficult, like the current models would be difficult in getting to know him, so couldn't give a perfect recommendation to him. And it also ignores the social influence among the students, as the main students would be on the they would be choosing events on their interests, and also on the social event from the peers, like from the students to students, like technical clubs and the friends. So there is a poor performance with the sparse and the short-lived event data. Yeah, this is the problem. The existing student recommendation systems recommendation systems fail to provide an accurate and relevant suggestions in dynamic, social-driven, and academic environments. So the key challenges here are as said earlier, the sparse interaction data and the cold start of the events. So there is a short-lived, as the events are short-lived and highly dynamic event cycles, and lack of effective modeling to the peer and social influences. So this is the proposed model. We are proposing the model of CSCL GNN, which is a cross-fuse semantic constructive learning GNN, like graph neural network model, which has a dual graph framework. First framework is the user and the event interaction graph, and other is the user to user social graph. And we are using light CGN based scalable representation. The objectives are a model is for both individual preferences and the social preferences, and improve the recommendation quality under the space and cold start settings, and ensure the semantic consistency using over the constructive learning. So this is a system architecture which consists of basically of the how the model works, how it is kind of recommending to the students, basically on the two user graphs. So these are the related and the related works which we did in a literature survey, and we found out like the traditional ML models are limited to the adaptability, and the content aware models are high computational costs, and the GNN based models are capture the structure but lack in semantic alignment. So main research gap what we identified, there is a no uniform there isn't a uniform model combining the interactions, social influence, and semantic consistency in it. So based on our model, we have the two graphs: user event interaction graph, where the nodes are the users, where the nodes are the students and the events. Edges represent the registration, clicks, and the attendance of the event, which are weighted by the interaction and importance. The next graph which we are doing is on the user to user social graph, which represents the other students or the friends, the clubs, or the classmates. Capture on the peer driven participation. The presentation model we are using this light CGN, which are linear neighbor aggregation, and it's reduced the noises in the sparse data. Best performance with the shallow layers. So, and other is a multi-head attention, which learns the importance of the neighbor, distinguish between the strong and the weak influences. This is the graphs how we did. So creates a semantic prototypes like these are the semantic prototype technical, cultural, and entertainment. These are the social view where the each node is a student and each edge is the interaction between the students. And based on that, based on it, we do it like basically like this is the technical like students which are interested in technical events. Other students so they formed a group which are interested in the cultural events and the vice versa. Based on their interaction, semantic prototype we connect to it, and interaction views are the events where each node is the event, and each edge is the event clicks and the registrations. So which this aligns with the social interaction and embeddings, enables meaningful recommendation for cold start users. So the training loss we are training on are the BPR loss, which improves the top K ranking, and graph constructive loss, which shows the structural consistency, and cross-view constructive loss, which aligns with the semantic alignment. So total loss would be the sum of it. These are the evaluation models which we have used, the hit ratio model and the normalized discontinued cumulative gain model. And we have got a score of nearly 0.82 for hit ratio and NDGC score to 0.78. And the precision out of 10, we got it 0.75. So these are the results we tested on our starting model. So the CL GNN performs an outperforms the baseline models up to 14% of the HR ratio in the cold start cases. Better ranking consistency and scalability. So the conclusion, unified modeling of the interaction of the I would like to conclude on the we are unifying the modeling of the interactions and the social influences and semantic fusion and effectively addressing the cold start and scalable and deployable for real college systems. So future integration would be incorporating with the temporal dynamics of the event, privacy awareness of the social modeling, and deployment at the multi-campus scale. Thank you. Any questions?
Am I audible?
Yes, ma'am.
Huh. One question. Are you preparing this project for only college event or some national event or
Ma'am, yes, ma'am. I understand. Like it's for
huh,
starting stage, we focused on the college event, ma'am, because there are many
okay.
models outside which are just focusing on the wider aspect rather than it's
Yes.
following the college events. So the main problem what I identify with my college is like in the surrounding colleges only we are
Hmm,
not
hmm.
able to know the which events are going unless we see the notice board or through WhatsApp. So I'm
Yes.
trying to provide like a platform with this integration approach. So I would be
Hmm.
starting on the small scale from college to college, and I would be integrating it to large scale, ma'am.
Okay.
Yes, ma'am.
Okay. Which platform you are used?
For the deployment, ma'am, we are using
Deployment?
currently for deployment of my project. We currently I'm building it on AWS, ma'am. So we are in
Okay.
the
AW.
like developing the web project, ma'am. For the first phase of it is like a web application, and the future
Okay.
phases would be app integration, ma'am.
Okay. Thank you.
Thank you, ma'am.
Thank you, sir, for your presentation. Now we'll move on to the next presenter. So the next presenter is Sheikh Hussein Bawasa from Mahakaushal University, Jabalpur. And the paper title is Adaptive Robotic Control in Automotive Assembly, a sensor fusion and simulation based framework. Sir, if you're there in the meeting, please start with your presentation. I don't think he has joined us yet, so we can go on to the next presenter. So the next presenter is Ravi Patel from Charotar University of Science and Technology. And the paper title is AI and Machine Learning Approaches for Kubernetes Cluster Orchestration, a comprehensive survey on performance optimization. So you can start with your presentation.
Okay. Good morning, all. L- Let me share my screen. Madam, please
Yes, sir,
allow.
now you'll be able to share.
Okay. I think my screen is visible to all.
Yes.
Okay. So my paper title is use of AI and machine learning techniques for Kubernetes cluster orchestration. And in this paper, we have surveyed how we can improve or how what are the available solution for performance optimization for the Kubernetes cluster orchestration. So why there is a problem or what are the motivation behind this survey? A- As we all know that Kubernetes become de facto container orchestration platform for all type of application. So it is widely used and it has some mechanisms like reactive approach and that is required some improvement, and it is actually struggling with the dynamic workload, over and under provisioning issues, and latency and cost inefficiency are there in the Kubernetes basic platforms. So to solving these problems there are various approach are proposed and that we are going to survey here. So in this scale, as you are aware, traditional auto scaling is not intelligent, right? So as we all know, the intelligent and machine learning applications now emerging as a magical solution for all type of problems, right? So this can be solved, this all issue that we have discussed can be solved using intelligent approach or intelligent orchestration. So for that, what ML can brings as per our survey, we can see that the predictive auto scaling is possible, intelligent scheduling is possible, adaptive load balancing, and proactive anomaly detections are the major use case of this ML, and how we can improve the performance for applying all these ML and AI related techniques. We can improve resource utilization, latency, throughput of the overall system, cost efficiency, and fault tolerance can be improved. And as per the survey or as per the papers that we have surveyed, these all are possible, right? So before starting, let us first discuss what exactly Kubernetes is. So Kubernetes is basically a very complex system that is basically a cluster, and where we can run our production grade workload, and in that there are actually client server model. And as we can see in the master node or in the server node, as we can see, we have various component like API server, controller, scheduler, database, key value store, right? We have a kubelet, container runtime systems, right? Then we have a concept of pod. So pod here means basically a container. So inside a pod we have containers, one or more containers, and we have a logical network proxy that is known as kube proxy, and that is the important component that connects to the other worker so that workload can be managed, right? And this is basically a cluster which orchestrate our containers, and for that they are wrapping all container inside a pod. So pod is a unit to hold our applications, right? And for that we are for managing all that, they are very intelligently use the we can say scheduler, controllers, and API servers. So here there are a lot of chances to improve or apply AI ML, and there are various techniques proposed, right? So we will discuss those part. As we can see where ML fits best. As per the survey, scheduler, at the stage of scheduler, reinforcement learning is heavily applied and is very useful. In autoscaler, we can go for the LSTM and GRU based algorithms. And for load balancer, we can use deep reinforcement learning. So as per the literature survey, these all are the solution, or these type of applications are used to solve particular problems of the component like scheduler, autoscaler, load balancer, right? So this is the where main use case of AI ML to the Kubernetes components. And ML techniques, there are various ML techniques like supervised learning, deep learning, reinforcement learning. So in that regression, time series, LSTM, bi-LSTM, GRU, transformer, DQN, PPO, DLR, MARL. So these all are techniques are applied in various stages of the Kubernetes to improve their performance, latency, quality, and operational issues. So there is no single model that fits to all workloads. This is the major challenge that we can see after survey, that we have seen that there is no such a model that fit with all type of workload, right? So this is what the major our survey result, that there is no single model yet exists that work with the all type of workload, right? Because for now all the solutions that are proposing are various algorithms for various component or for various purpose, and that actually add complexity. As we can see in auto scaling, we can use predictive models, LSTM, reduce and it will reduce the SLA violations. And there is always a trade-off, as we are aware. Dependency, model complexity, integration overhead, all will be there for the auto scaling. And for scheduling, we can improve the distributions of the load balancing, multi-zone or edge cluster benefits, and reduce the balance. We can reduce the imbalance, and we can also reduce the latency, and overall quality can be improved just by applying better scheduling and load balancing to the Kubernetes. And the major limitations that as per the survey is that it is the training time is high, right? And multi-agent coordination issue means multiple components are there, so there are coordination issues are there, right? And if you see the comparative analysis, basically overall improves the adaptability and efficiency, right? But with the cost, means it is high computation and complexity as per the ML models we are running on parallelly side by side. Then basically all models that we see are black box, so there is no explanation behind that. And then there is a lack of benchmarking, so there is no such a tool that can, or there is no such a benchmark available, so that we can prove our overall efficiency for the Kubernetes. And if you want to improve the performance, but you have to suffer with the operational issues and the computation issues that we face, like deployment and maintenance of the models, and coordination with all these models are difficult. So as per the survey, we can say that these all we have surveyed.
Sir,
Yes.
sorry for the interruption, but we are
Mhm.
past the presentation time. Can you please get to the conclusion?
Yes, we can conclude that there are major challenges still exist, like data sparsity, high inference and training cost, poor explainability, integration with other components of this Kubernetes cluster, and lack of standardized benchmarks are the major challenges still there in the Kubernetes AI related improvement solutions. And in future, one can go for the lightweight, resource-aware ML models, federated training, age-aware intelligence, explainable AI, and standard benchmarking and data sets can be created to apply it to the Kubernetes orchestration to improve the Kubernetes. And basically, we can say that AI ML has a significantly enhanced Kubernetes orchestration and at the production grade, and still, it needs a simple models, explainability, and standardization. That's all, madam. Thank you all.
Thank you, sir.
Thank you, sir, for your presentation. Now I'll move on to the next presenter. So the next presenter is Kanchana Devi from Vellore Institute of Technology, and the paper title is Exploration of Explainable AI in Crop Recommendation Systems for Smart Farming. Ma'am, you can start with your presentation.
Shakshi, kindly share the presentation. Yes, ma'am. Thank you, ma'am. Is my screen visible?
Yes,
Yes.
your screen is visible. You can put it in slideshow mode.
Okay.
Okay, good
So,
morning. Yes, 1 second, Sakshi. Good morning, everyone. This is my student Sakshi. She'll be presenting on exploration of explainable AI in crop recommendation system for smart farming. Over to you, Sakshi.
okay, thank you, ma'am. Good morning, Shaya ma'am and my fellow researchers. I am Sakshi Arora from Vellore Institute of Technology, Chennai. Today, I will be presenting our review-based research paper titled Exploration of Explainable AI in Crop Recommendation System for Smart Farming. This is a systematic review of 18 research papers, along with the design and implementation of a validated crop recommendation system to experimentally
Excuse me,
support the review findings.
Sakshi, your slides are not changing. You're on the
Uh,
same slide.
yeah, actually, I haven't changed one.
Hmm.
Okay. Now is it changed?
Yes.
Yes, Ma, you can proceed.
Okay. So as we all know that agriculture remains the backbone of many developing economies, which includes India as well. So farmers face increasing challenges such as climate variability, soil degradation, and the lack of data-driven guidances. So over the last decades, machine learning based crop recommendation systems have gained a lot of attentions. While these systems improve the prediction accuracy, but most of them lacks the interpretability, which is actually really critical for the farmer's trust. Coming to the problem statement, from our literature analysis, we have observed that most of the machine learning based crop recommendation systems behave as a black boxes, and farmers receives predictions without the explanations. So there's a lack of interpretability, which limits the real world adoption. So the core problem is not the accuracy alone, but the absence of transparency and explainability in AI-driven agricultural systems. So coming to motivation, so our major motivation comes from some of the observations, like Indian farmers often rely on experience-based crop selections rather than data-based, and which may lead to inconsistent yield. Then recent researchers highlights strong performance of machine learning models, but they have limited explainability. And then we have explainable AI has shown promising in healthcare and finance, but is underexplored in agriculture. Therefore, we have critically reviewed existing work and demonstrated how explainable AI can be practically integrated. So this is a system architecture. We have followed Prisma guidelines to perform a literature survey. So first, we have included around 18 reviewed journal papers published between 2019 and 2025. And the review focused majorly on machine learning models used for the crop recommendations, and then input features such as soil, nutrients, and climate data. Then presence of absence of explainability techniques and all. So coming to the methodology, these are the that we have done with each paper. First, we have find the index article. Then we have checked the suitability of the article. Then we have identified the machine learning models and explainable AI techniques. Then we have reviewed each article and extracted machine learning model data sets and metrics. And then we have analyzed its explainability aspect and then review the findings and prepare the literature. So this is my literature survey. Sticking to the time constraint, I have not added all the 18 literature surveys, but I have added only 4 of them. So I'll give an overview. So this research papers have worked on explainable AI techniques like SHAP and LIME. SHAP stands for Sharply Additive Explanations, and LIME stands for Local Interpretable Model Agnostic Explanations, along with DICE ML, which provides the counterfactual explanations to the farmers. So we have also implemented a prototype. Uh, it is actually not the main contribution, but it serves as a proof of concept and experimental validation of the review conclusions. So yeah, so methodology includes data set collection from the Kaggle, then data pre-processing and feature scaling, then training multiple machine learning models. We have included around 10 machine learning models, and then selecting the best machine model, which is best performing, that is the random forest, and then integrating the explainable AI techniques. This is the SHAP summary plot, which actually uh, shows the global features importance. So we can see that it is consistent with literature findings that potassium, humidity, and nitrogen were the most influential parameters. So this validate both the model behavior and the agricultural relevance. This is the LIME explanation. We have also added uh, the in the words, like in order to so that the farmers can understand what it actually means. So it basically takes an input of all the features and then it shows how much is the prediction probability. So we can see that the rice has the highest prediction probability of giving 96%. And we can see that there are some of the features that are negatively influencing it, which is on the left side, that is not right, and some are positively influencing it, that is on the right side. So we can see that rice, humidity, and phosphorus, nitrogen are on the right side, and they have a positive influence towards the prediction. And we also give the impact score of each prediction. Coming to the testing and performance metrics, we have done around 10 papers, 10 models actually, and we have added accuracy, evaluated using accuracy, precision, and recall. And we can see that random forest classifiers have outperformed all the other machine learning classifiers and giving a accuracy of 99.5%. So this is the result and observation. And most influential features of potassium, humidity, and nitrogen. And SHAP helped us to understand the feature impact visually, and LIME provided the clear instance-wise explanations. Coming to the conclusion, to conclude this paper, the paper contributes in two ways. First, a systematic review of 18 research paper, which highlights the trends, gaps, and limitations. And then a validated implementation, which demonstrates how explainable AI can be effectively applied. So explainable AI basically bridges the gap between the accurate model and real world adoption. So we have also seen that random forest combined with SHAP and LIME offers a practical and transparent solution for smart farming. So our future work would include integrating the real world data set and creating a farmer centric interfaces and integrating the IoT. So these are some of the references, and thank you for your time and attention.
Thank you, ma'am, for your presentation. And if there aren't any questions, we can move forward. So the next presenter is Sneha Padhyar from KSV University. And the paper title is From Fault Diagnosis to Resilience, the Role of ML and DL in Safety. Ma'am, you can start with your presentation.
Am I audible? Hello. Hello. Sakshi, am I audible?
Yes, ma'am, you can start.
Yeah. Yeah. Okay. Thank you.
Audible.
Yeah. Okay. Okay. Thank you, everyone. Thank you for the confirmation. Yeah. Okay. So, good morning, everyone. I'm going to present my paperwork having entitled "From Fault Diagnosis to Resilience: The Role of ML and DL in the Security and Safety." As As we all know, in recent decades, safety has become a priority across numerous engineering domains, prompting the development of strategies and technologies to address safety, risk, and the reliability challenges. Among these, machine learning and deep learning has emerged a powerful tools offering diverse algorithm adaptive to a wide range of applications. So, for that purpose, our paper addresses the gap by conducting a systematic bibliographic analysis to deliver a holistic understanding of ML and DL application in safety-related researches. For this, in a systematic bibliographic analysis, we have developed a following 6 steps SBA, which is known as the SBA process, in which we have selected 5 heading safety risk journal from preliminary, universal, and research to identify the categories keywords which are shown as the flow. So what we have done in our systematic bibliographic form for the safety, we have know that in the current era of the ML and DL, we have so many algorithms, we have the possibilities. So in our paper work, we have tried to make a certain kind of convenience review-based work which will be helpful for the any persons who want to resume their work in the safety concerns parameters. So we have done the SBA-based 6 steps processes in which the evolution of ML and DL from 2003 to 2025 up to the till date, we have tried to narrate it in our paper, which indicates that how it was previously helpful to its current role in the safety. Based on this, in the perspective of the different kinds of operations and the applications, how the ML and DL will be useful, it will be narrated in our paperwork. So initially starting with the applications perspective, which will be based on this its perspective of the application domain, MLDL is widely applied across the rotating machinery. It will be also used in the structural civil engineering, which will indicate the battery health monitoring and the emerging areas like a nuclear plant, aero engineers, and the maritime systems. It will also go into help to rotating equipment, which like in motors and the bearing, which is the larger cluster, which having different kinds of complex behavior, which will be suitable for the ML and DL. Ultimately, with the help of our domain analysis and the SBA improvement, which can be indicate that how it will be useful for the complex behavioral domains and how it is going to useful and how we can narrow down the use of the ML and DL in our applications perspective. So the different common tools and the algorithms which we have used in our systems are like neural networks, which will be most frequently used in any kind of ML techniques, and we all know that the different kinds of CNN which will be dominant, it will be useful for the real applications, which will be strong in the image object recognition and the large kind of data. We have also used the concept of RNN, GRU, RSCM, which will be used for the RUL. Well, the full form of the RUL stands for the remaining useful life predictions. So, as per the analysis work, the common tools and the algorithms are like neural networks, which are more frequently used in the ML techniques. CNN, which will be used to dominate DL applications, RNN, GRU, and LSTM, which will be widely used for the REL prediction and the sequential signals modeling. By referring our work, you can also get the historical, current, and future trends of ML in this analysis. As We have systematically estimated the work from the starting of the early phases of the ML and DL to the current kind of era. So in these, it has shown you a growth over the 20 years. In early phase, ML specifically, ML and SPMs was used in the damage detection and the rotating machinery diagnosis. In the span of 2011 to 2014, mature ML like the decision tree, which will be used for
Hello, Sneha madam, your slides are not changing, and I'm saying it is not relevant. What you are talking is not in front of the slide.
yeah, right now we currently, is it visible the common tools in the this slide?
Hello,
Yeah. Hello.
your slides were not changing, and what you are talking is not in the PPT.
Ma'am, all right now what slide you can appear?
I think application domain slide.
Yeah, ma'am. So I'm on the slide number 6, and according to so may I continue from this slide?
No, okay.
So ma'am, ultimately what I'm going to represent is like my paper is regarding a systematic based review on the ML and DL concepts, which will be used for the safety and the risk analysis parameters. So ultimately what it conducting and what I have tried to convey till these slides are like how ML and DL will be used for the safety perspective. So in that, different applications of MLs and DLs are widely used for the machinery safety regarding, which will be used for the largest clusters of the safety concerns in the industry's perspectives. The industries like aero engineers and the nuclear plant, how ML and DL work. In my work, we have tried to identify the how ML and DL as per the growth, it is systematically analyzed what are the different applications and how it is used, and if any person is going to use for the certain kinds of applications by using the ML and DL, our papers will be useful for that, and how ML and DL has carried out that particular generations, that particular systematic reviews we have showed. So as per the and my current slides are regarding the tools and technologies which are be applicable for the safety regarding that. So that are the neural networks, CNNs, RNNs, and the MLDL. So what I have done with the help of the ML and DL concepts, the different kinds of features, extractions, and selections, and the noise reductions in the turbines or the any kind of aeronautical part space, it will be useful because they having a different kinds of complex behavior. So which parameters will be used? So such kind of parameters can be easily estimated with the help of the ML and DL concepts. So based on that, in SVA analysis, a particular early phases of the ML to the current phase hasn't gone. So it is mentioned that in the early phases, ML was specifically used for with the concept of the ML. In NN and SPM, it will be used for the damage detection and the rotating machinery diagnosis. In the era of 2011 to 2014, the mature ML, like ML algorithms will be used. It is like
Hello. Ma'am, sorry for the interruption, but we are past the presentation time. Can you please get to the conclusion?
Sure. So these are the era of the different 2000 till now. These are the particular trends. So what ML and DL is it? So as in my conclusion, these are my last slides. So as in conclusion, we can simply refer this work if anyone want to go and pursue their ML and DL detection specifically for the industry safety concerns. Thank you.
Okay. Thank you, madam. No question.
Okay, ma'am. Now we will go on to the next presenter. The next presentation is by V. Siddharth from Amrita Vishwa Vidyapeetham, and the paper title is Interpretable Feature Selection for Speech Emotion Recognition in New Zealand English with Grid Search Optimization for Effective Hyperparameter Tuning. Sir, please start with your presentation.
Yes. I can see the screen.
Yes.
Yes, sir.
Good morning to one and all present here. Myself, B. Siddharth, and then my co-authors are Amara Pranav and Manju Khanna. Me and Pranav are from Department of Artificial Intelligence, and Dr. Manju Khanna is from the Department of Computer Science and Engineering. Now, moving on to the table of contents. So, we are going to present introduction, problem definition, objectives, data set description, the methodology, and the results and conclusion. So, coming to the introduction, speech emotion recognition aims to identify whatever the emotions are there from the speaker who is speaking, and it is a very fundamental component of the human computer interaction system. We can see that the emotions in the speech alter very important characteristics like the pitch, energy, rhythm, and chroma, and some other characteristics like the Mel frequency, substral coefficients, etc. We can see that in SCR literature, the emotions are broadly categorized into two categories, that is the primary emotions as well as the secondary emotions. Primary emotions are the emotions like happy, sad, neutral, etc. While and they are having very strong acoustic characteristics. But when we come to the secondary emotions, they are more or less derived from the primary emotions like anxious, concerned, etc. So they share overlapping properties with the primary emotions. We can see that most of the works are done on the English datasets, and SCR is more established in that domain. But when it comes to the New Zealand dialect of English, it is largely underexplored in the SCR research. Now, let me address the problem statement that we are trying to address in the study. So, we can see that speech emotion recognition is a very subjective and acoustically complex task. And this problem becomes more pronounced when we are considering the secondary emotions, because the secondary emotions share overlapping properties with the primary emotions. And we can see that in most of the studies, the feature sets that is extracted is of high dimensions, or either it will be of low dimensions. If it is of high dimensions, it introduces redundancy, and it might also cause the model to overfit. And as a result, we can see that, and most of the studies, we can see that they have also used one-dimensional CNN and all that, and deep learning architecture. As a result, they reduce the interpretability, and therefore, and also we can see that not much work has been done in the New Zealand dialect of English. This necessitates the creation of the interpretable interpretable speech emotion recognition, especially for this data set. So the objectives of this study is to design a speech emotion recognition system particularly designed for the New Zealand dialect of English, and we seek to extract 132-dimensional comprehensive and interpretable speech features for the New Zealand English. And then we use the grid search optimization algorithm to find the optimal hyperparameters, four optimal hyperparameters of the random forest model. And then we use the recursive feature elimination technique to discard the redundant features. Like instead of using all the 132 dimensional features, we need to see which features make more contribution towards the emotion discrimination, and those features have to be selected, for which we use the recursive feature elimination. And then we analyze the emotional class separability using the T-distributed stochastic neighbor embedding visualization. And then we use the Shapley additive explanations to provide the feature level explainability of prediction as to how the model has reached to that particular prediction. Now, coming to the literature survey, in the year of 2023, we can see that the first paper has extracted the MFCC-based features, and then they have used the three data sets of English, that is RAVTEST, TEST, and CAV, and they have proposed a two-dimensional CNN architecture with self-attention mechanism, and on the combined data set, they get 90.19% accuracy, and they have also applied data augmentation techniques, but then there is an issue of reproducibility because the seats are not specified. And the second study uses the MODB as well as the JL corpus, and then they are seeing the effect of emotion on the verbal formats. And the third study in the year of 2024 has extracted only the MFCC features from these three datasets, and then they have run multiple machine learning classifiers like SVM, RF, and KNN, and they have used CAD boost ensembling technique as well. And when individual dataset is taken, they're achieving 100% accuracy on tests. This is because of the small size of the dataset of the test, and probable overfitting also might be there on the individual dataset of tests, but when the overall dataset is combined, they are achieving significantly lesser results. And then the another study has used the JL corpus, where they are analyzing the difference between the fundamental frequency as well as the pitch across the 10 different emotions, and then they are giving statistical differences. Now, moving on to the dataset that we have utilized in this work, the dataset that we are utilizing is a publicly available CAGBIL dataset called as the JL corpus that is designed for New Zealand English. It has 10 different emotion classes, and we have from the literature survey, it can be seen that most of the studies have been done on the English dataset, but no one has used the New Zealand datasets. And then they have considered only the 6 to 7 emotion classes, and therefore it is a slightly easier problem. But when it comes to 10 different emotion classes and to visualize the features, it's a very complicated task. So this study tries to address that. And then and the secondary emotions are also considered in the study. So primary and secondary emotions are considered, and then there are four long vowels which are given to each speaker: A, O, I, U phonetics, and then total utterances that is achieved is 2,400. And for each emotion, we can get 240 emotions. So that's the balance. Like each emotion has 240 samples. And then it is recorded at 44.1 kilohertz, which is later resampled to 16 kilohertz. Moving on to the proposed methodology, the data, since the utterances of different length, we have either zero padded or truncated to make sure that everything will be of the same length. And then we have extracted a series of 132 dimensional features like the substell features, that is smell frequency substell coefficients, the delta and the delta square, that is the first and second derivatives of MFCCs. And then we have extracted chroma features, a total of 12 chroma features, and the voice quality features, that is the jitter, shimmer, harmonics to noise ratio, etc. And a wide variety of spectral features, that is the spectral contrast, spectral roll-off, spectral bandwidth, etc. And also multiple prosodic features, that is the pitch, tempo, zero crossing rate, root mean square energy, etc. Total, this resulted in a 132 dimensional vector. And then this was passed to a random forest model. But in order to make sure that we are getting the optimal values of the hyperparameters of the random forest. We have tested across the different, like for number of estimators, we have tested different values. Maximum depth of the trees, we have estimated these values. Then minimum sample split and minimum sample sleeve, we have tested with this different kind of values. And whatever the optimized value that we got from the grid search, that is 200 estimators, then 20 as the maximum depth. Then minimum sample split for leaf is 2, per node is 2, and per leaf is 1. So using this model, what we did is in we have passed this to recursive feature elimination. Like instead of considering all the 132 features at once, we are trying to train with different numbers of features. That is 30 features, 50 feature subset, 75 feature subset, 80 feature subset, 100, and the entire 132 feature subset, to make sure that having how much number of features will be resulting
Sir,
in an
sorry,
optimal performance
the
and the
interruption.
accuracy.
Sir, can you please get to the conclusion?
Okay, yes, ma'am. And then we have visualized with TSNE, and then we have your SHAP for explainability. So we can see that the best performance is 74.2%, which we have obtained with 80 features from the random forest. And this is after the feature feature extraction, and this is after the model training. We can see that the clusters have become more different. That is, the feature selection has benefited widely. And then we can see the most important features from the SHAP, that is RMS standard deviation and RMS mean. And here we can see how the two features are interacting with each other. So we can see that an interpretable speech emotion recognition has been successfully developed for New Zealand English. We can see that there's an optimal balance that is achieved with 80 discriminative features. And then we can also see what are the emotional indicators, that is root mean square energy, mel frequency, substral coefficients, that are the most common emotion indicators. The future work would benefit from extending it to larger data sets, as well as to explore some semi-supervised and ensemble learning approaches. And then we could also improve the accuracy. Like currently it is only 54% for the encouraging class. We can try to improve the accuracies for the subtle secondary emotions by considering more deeper architectures like deep learning architectures like CNN, and then to investigate real-time deployment on AWS cloud or something like that. Thank you for giving us this opportunity to present our work.
Thank you. Siddharth, have you used real-time data?
No, ma'am. This data set is publicly available in Kaggle, and this is of the speakers who are speaking the words in real, but it's a Kaggle data set.
Kaggle data.
The sentences were given to the speakers, to a total of 10 speakers, to speak all the different kind of sentences in New Zealand English.
Okay, have you considered the age?
I think most of the speakers in the data set were around 25 to 40 years of age.
Because again, that pronunciations and again that will be matters, na?
Yes, ma'am. Most of them were in the age group of 25 to 40.
Acha. But you are not selected as one of the feature age group.
No, ma'am. We only wanted to see the speech-related features like jitter, shimmer, that is the changes in amplitude and changes in pitch. So all that will be considered when, like how the voice is, we are not trying to see the gender or something, like how the voice quality features we were trying to extract.
No, no, no. I'm talking about the pitch of the voice. Again, it
Yes, ma'am. Pitch
varies,
also
na?
has been extracted. It is a
Yes.
prosthetic feature.
Okay. Thank you.
Thank you.
Over to Siddhi.
So the next presenter is
Is my slide is visible?
Yes.
Yeah. May I
yes,
start?
ma'am. Your slide is visible.
Okay.
You can start with your presentation.
Yeah. Good morning, everyone. I'm going to present my work on the next generation network security ML-based attack detection. So as we all know that the rapid growth of IoT, cloud, and the large network usage has always invited the different kind of cyber attacks. So for that, we required a certain kind of security regarding setup, which will be trying to prevent such kind of network regarding threats. So we have over the network and over the security, we have the different kinds of modern intrusion detection systems for the multi-layer of the protections, but helping with the help of only intrusion detection systems will be not right now possible, because through having a certain kind of ideas regarding facilities, we are still facing a different kinds of key challenges, like in low accuracy point of view, different kind of evolving a new attack based traffic pattern, rare and the unknown different kinds of attacks are also there, large numbers of volumes over the network usages, and the multiple access points issues are also there. So for that, in the network security concerns, with the help of intrusion detection systems, a need of ML and DLs are also there. The reasons are, on the intrusion detection system, we have the very first facilities of the signature based intrusion detection system, but which will be only and only useful for the attack which having a specific and the predefined identity. It will be a foil on the certain kind of 0 day based attacks which don't have the certain kind of known behaviors. Again, a second kind of thing is we have the anomaly based intrusion detection systems, but they having a laser accuracy points and they having the higher kind of false alarm regarding point. So this the help with the signature and anomaly based detection systems, we require to use the adoptions of the ML and the DL based algorithms, which will trying to learn the attack behavior, and it will improve the classifications of the identity. With the help of the deep learning, it will improve and it will reduce the false positive, and it will improve the reliability of the time. So with this concept, we have proposed our work into the different 5 sectors. We have tried to identify that which algorithms will be useful with the context of what parameters, and with the help of the what network characteristics and the attacker's identity, to identify that it is the legitimate traffic or it is the normal traffic. So based on that, our problem statement will follow a different kinds of attack type. It will be used to identify a normal traffic flow, and it will try to identify if the traffic is malicious, then what kind of attack is going to happening on that particular type. So this is the what a problem statement of our time. With this, we have tried to identify the flow, like we have the concept of the network traffic. In the network typing, a different type of features extractions will be done by using the ML and DL algorithm. Then it will try to identify that it is a normal traffic, it is the attack traffic, what kind of attacks is that, what kind of accuracies will be there, it will trying to identify in our methodology section. To identify such kind of methodology and to get the results, we have used the dataset named UNSV NB15, which having a total 2.5 millions of data samples. Among the 2.5 millions, we having the 2.2 as in million as in normal data flow, and remaining 3 millions are what according remaining 0.3 millions are according to the attack base identified. So base of the clusters of normals and the malicious, our methods and our proposed approach will be identify the traffic from the normal and the malicious traffic. So for that, we have used the 7 different models, a classical ML like SVM, KNN, decision trees, and the random forest, Ansible models like AdaBoost and Execute, and in the deep learning, we have used the layers of the deep MLP layers. So for that, we have used the different evaluation metrics like accuracy, precision, recall, F1 score, ROC score, and the confusion metrics of the true positive, negative, and the false positive and false negative. So for that, we have tried to examining our data set on the our proposed flow. It will try to it will go with the each and every mentions ML and DL algorithms, and based on that, a different different executions will be done, which executions we have developed with the help of the Pythons and the Keras 2.1. So in that, after the conclusions and after the performance, we have evaluated that database onto the our MLDL algorithm. We have get the different performance like in decision tree. We have received a very base performance of 99% of accuracy on that particular data set, which having the score of 0.97 as an F1. KNN has a K different as K specific value of 7, which we have been giving a 95.58 accuracy. SVM will give the 95% of accuracy with the 99.93 F1 of score. So these are the particular results and the discussion points. We have tried to evaluate certain kinds of each and every algorithms, the attacks, their accuracy points in our details in our papers. So these are the what are random samples flows for the PPT perspectives. So which will give you the accuracy rate. The table has mentioned the correctness, decision rates, and F1 score. Among these all the algorithms, we have received a very good accuracy points in the decision trees. The correctness points is also good in the decision trees, regarding with 0.98, and the decision rate is what detection rate is 0.97, 97 as an F1 score. So as a conclusion, if we are working on the network and still we are facing a certain kind of signatures and anomaly based detections approaches, but a touch of ML and DM will be useful for the known behavioral base of attacks, and it will be helpful to identify certain kind of things by using this ML. Yeah, thank you.
Thank you, ma'am, for your presentation.
Thank you.
Yeah, thank you.
Are there any questions or shall I proceed further?
You can proceed.
Okay, thank you, ma'am.
So the next presenter is KJ Anantakrishnan from Amrita Vishwa Vidyapeetham, and the paper title is Overcoming Ergonomic Challenges in Remote Software Development, a Vocation Perspective. Sir, please start.
Okay. Thank you, Siddhi. Hope my screen is visible.
Yes, yes. Yes,
Uh,
visible.
Yeah. So good morning, ma'am, and good morning to all the others present here. So today I'm going to present my paper with the ID 267 titled Overcoming Economic Challenges in Remote Software Development, a Vocational Perspective. My name is KJ Anantakrishnan, and I am an MBA student for studying Operations in Analytics from Amrita School of Business, Coimbatore. And there are two other co-authors with me. One is Ms. Alka and Dr. Suresh M. So for the introduction, the remote software development is post-COVID, the remote software development is something that has come into the picture. So work is actually transitioning from an office setup to a more remote kind of environment. And there is workation as a new aspect to that. So workation is like we'll be combining the remote software with the leisure time, leisure travel. So we'll travel in work. That is the basic idea. And because of this, there are new sets of challenges that are coming in, both physical, psychological, and occupational well-being. And these risks and challenges in remote work environment are actually not looked upon. So there are certain different set of factors that these are affecting into. Most people actually, most of the researches that we have actually seen are looking into the impacts of that, basically saying the related to the neck pain, the back pain, and all these other things. And the result-oriented approach is not actually seen. And the methodology that we are following is called as GINA, that is Gray Influential Analysis. It is like we'll be defining the set of factors, and with the set of factors, we'll identify which are the most important factors. So why are we doing this research? It is like we are doing three sets of gaps that we have found in the area. The one is like people are actually focused on the remote work alone. They are not looked upon this workation kind of perspective. The gap two is like people are focused mostly on the negative set of impacts, like as I said earlier, like the pain or dissatisfaction. They are not focused on a solution kind of approach where how we'll identify what are the factors and how we can overcome them. And a methodological thing is like a dynamic relationship between these sets of factors that are affecting this, and the correlation between them and are not studied. So that is where our research comes into the picture. And the objective that we are doing is like to quantify the influence. We've identified 7 set of factors, and with these set of factors, we'll identify which how these sets of factors are affecting the economic challenges, and to identify the key drivers in the sense from these sets of factors which are the most influential that are affecting both the workers as well as affecting all the subsequent other sets of factors. So for the methodology, we are using something called as GINA. So GINA is gray influential analysis. It is like we'll identify certain sets of factors. Mostly seven factors are used in this particular context, and we'll collect data from data in order to find the relationship between these 7 sets of factors. The core idea is to find the correlation between them. So we have collected data from 25 experts, and 23 have been taken in for the analysis with the help of snowball sampling. And some of the responses, 2 of the responses have been removed because of inaccuracy or bias kind of issues. So how we have identified these set of respondents is like they should have a minimum practical experience of 1 year, and they should be willing to participate in the study, and they should be working in software development domain, and the confidentiality and anonymity has been maintained. So it has been done using personal interview as well as online set of interview, where they were given a set of 42 questions in correlation, the 7 factors in correlation with the subsequent other factors. That is, the factor one will be correlated with the other 6 sets of factors. Likewise, the 42 set of questionnaire has been given, and with the use of Likert scaling, they were asked to give the response. So they interpreted, and we have collected the data, and the interpretations were done. So this is how we have done it. So these are the 7 sets of factors that we have identified. Establishing ergonomic guidelines is the first factor, then encourage regular check-ins and feedback, then the promote flexible work schedules being the third, implement wellness programs being the fourth, leverage technology of ergonomic monitoring being the fifth, provide ergonomic budgets or stipends the sixth, and last one being cognitive load management through personalized assessment. So once this were done, the questionnaires we collected, we used the GINA methodology, went to the respondent, collected the respondents, and then we cleaned the response. So after cleaning, it has been converted to grayscale. Grayscale in the sense there will be a lower bound and upper bound to that for every particular value that we will be getting. It should be explained later. And after getting that, the aggregate values were found, and we'll whitenize that. And after that, direct influential coefficients. There are 2 factors called GRC and GAC. These 2 factors will be identified, and with the help of that, we'll be identifying the most influential factors. So this is the scale. So if you see here, we have 5 different sets of values from very low, medium, high, and very high. So the upper bound for in the measuring the GINA analysis, the lower bound is 0, the upper bound is 3. So for each set of values, we'll be calculating these, and 3 sets of table we have getting. The 3 sets of table are critical, ideal, and typical. Critical is the most basic value that we'll be getting from the clients, and ideal is the ideal kind of scenario that could happen, and typical is the scenario that is coming in between that we are focused upon. So This is the results that we have got as the aggregate value of all the data, the quantified value of all the data that we have collected have been given in this picture. And this is the GIC and GRC. And with the help of this, if you see there, the total influence of OF3 and OF6 is coming to 0.29. So these two sets of factors, when compared to all the other set of factors, is coming as the most highest value. And these two set of values have been taken as the most influential factors. And that is where. So how we have identified is like using the 80-20 rule. So 80-20 rule says that 20% of the solution accounts to 80% of this problem. And by this, we have identified these two being first being provide economic budgets and stipends, which is OF6, and the second being promote flexible work schedules. And these two factors are the most foundational elements, and they have an effect with the respondents as well as an effect with the subsequent other factors that are related. So that is what I said, like they are not just isolated. We should not just focus on these particular factors. They have the most influence on the other set of factors. See, for example, the role of flexible work schedules, if I am taking that, so it impacts the economic guidelines and regular check-ins. So if economic guidelines and regular check-ins are followed, flexible work schedule has to be maintained so that people could take a rest. Even if the guidelines are there, they could take a rest, maybe for their eyesight, have a stretch. All these set of things could be followed, and it also has an effect on cognitive load management. And when it comes to economic budgets, wellness programs and technology monitoring has the most correlation with that. And even if wellness programs and technology monitoring have to be implemented, this budget is required so that people could. Yeah.
Sorry for the interruption, but we are past the presentation time.
Yeah, sure. So this is the limitations that we have found. The sample size, the geographical scope, the factor escalation, and the cross-sectional natures are the issues that we have found. And the recommendation is like, in conclusion, the recommendations that we could give is like economic budgets or stipends should be given to the professionals, implement flexible work schedules so that people will be flexible enough to work for, and the managers should be focusing on the economic framework so that they could work on. The policymakers should intervene to promote this occupational health. And the future research scope also lies in these areas, the longitudinal, because we have only focused here upon this particular time period. It could focus more on the next set of period and include additional factors. We have identified different sets of factors like leadership styles or culture, which could be incorporated. The demographics, in the sense, it is focused only on India. We can focus on other regions as well. And the sector analysis, we are focused on the IT software development as of now, and more could be incorporated. These are the set of references, and thank you.
Thank you.
Thank you, sir, for your presentation. Now we will go on to the next presenter. So the next presenter is Dhaval Anarkat from Marwadi University, India. And the paper title is Secure and Intelligent Casting, Blockchain and IIoT in CPS-Driven Vertical Centrifugal. Sir, please start with your presentation.
Thank you, Siddhi, for inviting me for the presentation. So right now I'll share my screen. Is my screen visible?
Yes, sir.
Wait. Sorry for this thing. Just wait. My PPT is visible now?
Showing not PPT. It's not showing PPT.
Okay.
Some other documents.
Yes. So I'll close everything else now. Just one moment, please. Documents. Now, is it showing my PPT?
Yes, sir.
Yes.
Okay. Sorry for the earlier confusion. Yes. So good morning, everyone. My name is Dhawal Unadkat. I'm a assistant professor and a research scholar at Marwadi University. My other authors are Sumit Ranolia, who is one of my undergraduate students, then Dr. Amit Sata, Dr. Tripti Sharma, and Dr. Ritvisha. Topic of my presentation is Secure and Intelligent Casting, Blockchain and IoT in CPS-driven Vertical Centrifugal Casting. My paper ID is 297. Contents of my presentation are introduction, literature review, bibliometric analysis, motivation, methodology, framework, development of CPS-enabled VCC, experimental setup and data collection, interaction through digital twin, conclusion, blueprint for the future, and references. So actually, if we go through this manufacturing scenario, then in recent times, global manufacturing is shifting towards Industry 4.0, where technologies like IoT, AI, digital twin, AR, VR, blockchain, and cyber physical systems are modernizing the traditional processes of the production. In this global manufacturing, metal casting plays a vital role in the manufacturing process as it is used to produce the different types of components of different complexity with very easiness. Among these different metal casting processes, one of the metal casting processes is called vertical centrifugal casting, which is a process used to produce hollow cylindrical components through a high-speed mold rotation. But this process still lags to produce specific type of components because of its complexity and inability for the monitoring. So integrating this cyber physical system and different disciplinary technologies into VCC enables real-time monitoring, intelligent decision making, automation, and prediction of the defects using different sensors, cloud systems, and machine learning. This is the literature survey that has been carried out in the process of developing this research paper. So different researchers have worked in the direction of cyber physical system, casting, vertical centrifugal casting, manufacturing in different domains. But very few researchers, rarely, people have worked in the direction of cyber physical system and this disruptive technologies in vertical centrifugal casting, which makes it very less researched domain. And that's why a bibliometric analysis has been carried out with the keyword cyber physical system for manufacturing from the data sources Scopus and Web of Science. And this result shows that how many articles, proceeding papers, reviews, early access book chapters, and number of things have been published by the different people. Now, study period has been taken as in 2015 to 2025, 10 years of this span. Total of 5,702 research papers have been figured out or done by the people. This is the merged database of both Web of Science and Scopus. An analysis tool has been used as an RStudio. And what has been focused when this bibliometric analysis was carried out is citations, keywords, collaboration, and trends. Then this bibliometric insight shows different trends that research has been growth after 2018. Then China, US, and Germany lead in the publication among the most cited countries, whereas New Zealand leads in average citation per document, which is 141 plus, right? And more than 16% international collaboration has been observed, means people are working in more collaboration in these domains. Also, as in the terms of authors and institution, more than 12,362 authors have contributed in this domain, where Chinese academic science becomes most productive globally. IIT Systems has the highest contributor in the India, and Dr. Lee Ji is identified as a top cited researcher in this domain. So the motivation behind this research is on CPS integrated manufacturing is because it is expanding very rapidly in the industries. Also, there is a recent studies which shows strong alignment between CPS and Industry 4.0 goals, whereas traditional casting processes still lacks widespread implementation of these technologies because of traditional mentalities most of the time. Very limited research applies this CPS to VCC directly. So that is also one of the research motivation. And there is a strong need for real-time monitoring, defect reduction, and intelligent control in vertical centrifugal casting. So developing and demonstrating a CPS-based process model is essential for smart foundry transformations. Methodology applied in this is development of a vertical centrifugal casting setup, then integration of sensors and actuators with the setup, development of a cyber physical enabled data acquisition system, then data acquisition, processing and transfer to the data cloud or edge nodes, and then development of cyber physical systems. And last one is experimentation, validation, and CPS performance analysis. So all of this has been carried out. This is the framework for CPS enabled metal casting. So how it has been carried out? Initially, an experimental setup was developed of vertical centrifugal casting. This is a 3D model and this is the real setup. Then various sensors were integrated with the system. K-type thermocouple is used to measure the furnace temperature. Then magnetic Halt sensor are used to track the molds RPM, and DHT11 and LM35 are used for the monitoring room temperature and humidity. And this whole system is something like this, where as you can see, we have this setup, then data acquisition system, and this node MC and everything is here. Data is sent to the cloud-based server, and everything can be monitored on this mobile application. For this, to perform the experiment, a benchmark shape was designed. Then experiments have been carried out with these different parameters where pouring temperature and rotational speed are maintained. Defect are shrinkage and shrinkage porosity, and alloy composition are used as an LM25 and LM6. Then temperature sensors continuously monitor the process. Then each casting has been performed and inspected manually. Then inspection through digital twin, interaction through digital twin has been done, where this interaction, as you can see on the screen, that we have created a digital twin of the same setup, and a person can go digitally inside the laboratory and operate the machine. And the beauty is that when a person is inside the virtual reality room or a digital twin, a machine which is vertical centrifugal casting, as well as this bottom pouring furnace, there is melting furnace written over here. A person can operate these furnaces and with a VCC setup from this virtual reality room, and the same is replicated in or same is operated in the real world itself. So when a person start
Sir,
this setup from,
sorry
yeah,
for the interruption, but we are past the presentation time. Can you
yes,
please get to the
sure, I will. Thank you. So a person from virtual reality setup can work, and the setup will be operated in the real time. That is what has been developed. So the conclusion is that cyber physical system proves to be feasible and stable for real-time monitoring and consistent sensors performance. Digital twin accuracy was validated through precise furnace temperature and speed ratings. VR improves user interactions, and system is supported by Industry 4.0 by offering smart, scalable, and less operator dependent casting setup. For future, more such setups can be developed, and this is one setup, but a combination of these different setup can be developed. That is the next future, and these are the references that has been used for this paper. Thank you.
Nice presentation, Dhaval sir, and
Thank you, ma'am.
nice work also.
Thank you.
Okay, good work. Thank you.
Thank you, ma'am. Thank you, sir. Now all of the presentations are mostly done. I would like to call out one name before proceeding to the closing remarks. Sheikh Hussein Babasab. If any of the co-authors or authors are present from this participants, so they can present right now, or I can proceed further. Okay, then we can move on to the closing remarks. So I sincerely thank our authors for their excellent presentations and contributions in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for your support during the 10th version and all the previous 9 versions of this conference. We will be happy to have you in the 11th version in 2026. All the presenters would be getting their digital certificates via email within 2 working days. The publications will be live within 7 to 8 months. Kindly cooperate with the team of ICTCS 2025. I also thank our session chair, Dr. Chaya Zadhav, for chairing this session. A token of appreciation to the chair on behalf of Team ICTCS and Global Knowledge Research Foundation and partners. Thank you, ma'am, for your valuable presence. I Now, before ending this session, I request all of the participants to please switch on their cameras so that I can take a quick snapshot of today's conference. We'll just wait for a few seconds for everyone to switch on their cameras. Okay, done. I've taken the snapshot. Thank you, everybody. This was a great session. Now we can
Thank you,
leave the
Siddhi.
meet. Thank you, ma'am.